Hello and welcome back to Stationeers. I'm Mick. Today we're going to be doing a pretty fancy build. Well, I hope so. Or a pretty fancy failure. Either way, it's going to be pretty epic. Now we've been building up to this one for a while. We've been doing little bits and pieces of it in other builds, so we've finally arrived today as our special anniversary special of 6 and a little bit months. Or a bit of if that number's a bit weird for you, it's video 69 celebration. We're going to be putting things together and redoing our furnace. We'll go right back to our first video where we started with the furnace, and we're going to build a fully automatic furnace this time out. So I've set up a bit of our starting area. We've got our ore dispensers over here, which we've built in the last video, or a variation of it. Yeah, do the same thing. We've got our fuel system over there, and I've got some water up there so I don't die. So we're going to be looking at building a fully automatic one-touch furnace where you pick an ingot, push a button, and away we go. But enough yapping. The sun's coming up. It's time to get moving. Now bear in mind, this is an experimental build. I have not built this before. I'm making it up as I go along. And I did a bit of that with the gas generator, and people like the design process, so I thought I may as well do it again. I'll video the whole lot. Now I'm going to do a fully automatic furnace. It will have to self-regulate. I figure I'll do it using the hot and cold gas method, which you've seen on a few other people do, but I'm going to try and make it pretty compact. I've set out some rules for myself there to try and achieve. Now I'm going to give myself six frame areas to build it in, so I guess I'll be building it sort of in that sort of a space up there. If I build it too high and 3 wide, it'll give me more space to put on a big instrument panel. So that's the space I'm going to try and limit myself to. So it'll be something you can build in survival mode. It's not going to be something that requires 100 square kilometers to actually build the whole thing there. So it's going to be pretty compact, pretty material responsive, and it's got to actually work on all planets. So in terms of fueling system, I'm going to go with a gas fuel, because we can do gas on any planet, whether it's got an atmosphere or not. Admittedly, on Venus and Vulcan, you are very short of oxygen, so you could swap out the fuel system for an electric one. So depending on how we go, I might see if I can build an electric one as well. But let's start with a gas one. I have a little bit of an idea on what we're going to do, but as I say, it's an experimental build, so failure is definitely an option. If it does all fail, enjoy the design process and maybe pick up something from the way things are designed, or I guess if you're watching this video, I've uploaded it, so maybe something did happen. But anyway, it'll be a surprise to me because I haven't done it yet. So I've got a basic idea of what I want to start off with, so I'll get a building and pop down some hardware, and we'll have a quick look at what I'm proposing. So first up, we shall need our furnace, of course. Where are we? Advanced furnace. So I'm thinking I can pop you there. I was in creative mode, so easy. So you'll be sitting there. So that's your output there. Input on that side, that's fine. Now, in order to create the hot and cold tanks, I'm thinking I shall be using our basic furnace. Now, to get your advanced furnace, you have to have steel, so I'm guessing that you've built a basic furnace somewhere along the line, and it's probably kicking around in the back somewhere, in a cupboard somewhere, not doing anything, so we may as well use it. And where can I put that? I'll encase that completely in the block. Right. That's basically 2 of my 6 blocks taken up. And on top of that, of course, we'll need our insulated tanks. Where are you? There you go. Now I'll put the leads at the back. Up we go. Now I'll need a hot tank, a cold tank, and probably a waste tank as well. So as when we're on, say, a planet without an atmosphere like the Moon or Mimas, we'll be able to capture the waste gases from the tank, from the furnace, and use them, those gases, we can just heat them up and use them as hot and cold gases. That's basically how it is. So we're going to fuel this furnace. That will produce the hot gas, and we'll mix the hot and cold gases into this furnace to grab our temperature and pressure, and the exhaust from that will go into the waste tank and be reused, because it'll come out of there still fairly hot, so we can hopefully reuse it. But anyway, we shall need some pipes. So what I figure is we're using this furnace to do this, so I would like to, when I extract the hot gas from that, is to not extract the fuel as well. So I plan to put in a filter. So if I put you in, say, okay, you're outside of my block, but I can probably feng shui it a bit later on. So if we put you there, so you'll be able to suck the hot gas out and leave the fuels in the furnace. So if I put in an oxygen and a hydrogen filter in there, that'll just push all the gases back into the furnace, and everything else that's not combustible will be our hot gas that we'll use in the other furnace. That makes sense. So if I have a hot and cold tank, I'll need to put them both into here. So I will need, that's the input. So if I put a T-piece on there, I only want one section of gas in, one section of pipe in here. Because if I put my input to 100 litres and leave it at 100 litres, it will always empty that completely every game tick, no matter what I put in there. So then I shall pump my hot and cold gases into that. Now I can use a mixer, but mixers are rather slow. So I'm going to use volume pumps, because if they're hooked up to a high pressure source, they are very fast. If I can turn it around the right way, there we go. So I'll have you, and one for the hot and one for the cold. So if the heater's there, if I make that the hot tank, that'll be the waste, that'll be the cold. So I shall need a pipe. Nope, not you. So if you come out to your connector there, so you'll be the cold pipe, you shall be the waste. And you shall come out to there. The hot pipe will have to come across to you. And the cold pipe can come to you. Easy. So that should be all the connections I need to that furnace. Although I'll probably, now I'll save that, so I'll need to put some sensors on these pipes so as we know what temperature and pressure we've got to control the volume pumps. Right. So that'll do us. Right, so we're good. So this one, now the output on this one is just an extension of the chamber. There is a valve on the input which will stop us from blowing stuff in there until it reaches inside, but if I can actually still blow stuff in the output pipe, not a problem. So if I just use that and ignore the input, I should be able to just connect them straight up to here and straight back in, I guess. Come on. Yeah. So if I put my hydrogen oxygen filters in there, they'll filter out everything or go to the waste pipe that isn't hydrogen oxygen, which will be just our hot gases. And whoops, they can join into the hot tank. So I just need my fuel will also be going into this pipe here. So I shall need a mixer, turn around and around, that'll do us. Have some pipes, you should be good there. So you shall be our hydrogen, and you shall be our oxygen. Boom, into the mixer. So now as the gas becomes hot enough, we just pour gas into there, ignite it. As it becomes hot enough, I can just pull it straight out from here using this and leave the gas in there to be used. Now if it gets too hot, we can reclaim gas from the waste tank. So once again, I shall need a volume pump which can connect from there into okay. How about there? Volume pump pointing down into there. I've got to jump that pipe over that one. Okay. Our cold tank we will top up once again from the waste tank, I guess. That way. So if I put you there, that can hook into the cold tank just there. Right, so some more pipes. Right, you can hook into there, there. You hook into there, and oh, I see. I'm going to have to go through the frame. I don't like going through the frames, but I can re-feng shui them. No, that's not different. There, 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 there. You can come down that way. Now I don't like running pipes through frames, that's just asking for trouble, but I may be able to reorganise things and get them on the outside depending on how we go. These ones are unfortunately going to be inside there. If I want the furnace forward and just one block in there, I don't have much choice on that one, so we shall see how we go. Right, so I might just run some power and paint those pipes so it's a bit easier to read. That's looking a bit better. One thing I did miss, we shall need a insulator pipes. There we go. Our waste tank, or a cold tank, we shall need a way of cooling it down. Hence the name, cold tank. So I shall need to put some radiators on there as well. And some radiators with a digital valve. And stationary valve. Right, that'll work for us. Once again, quick coat of paint, and so the outlet will top up the waste, it'll top up the furnace where it can be heated up, the mixers output into the hot goes back into the furnace, cold goes back into the furnace. That's about the hardware I want. Now I can wire this side separate circuit to that one there so they're both isolated. That might be the easiest way to go for wiring. Okay, computer, a chip for this side, a chip for that side, maybe some transformers, and we'll power it up. Rightio. Right, that all looks hooked up. So I want you and you, and we should be good to go. Nice, nice, nice. Yep. Good, good. Now I do have gas in the pipes. Yep, oxygen and hydrogen, we're good to go. So now, of course, to set this one, I'll get that out of my way. So input 1 is the oxygen. So we want that to 3367, which will give us a good burn. And that should feed directly into the furnace, which we cannot ignite because that will be sealed in a block. Right, you should be sealed up too. We'll get to you later. So we're just going to write the side of the code which manages our tanks. So we had to hook up 1, 2, 3, 4, 5, 6. The tanks 7, 8. I better hook up the data for the tanks. Oops. Right, that's some ugly wiring, but it's all done. I will have to label everything now too, or it's not going to go very far. It'll be as confusing as hell. Right, so we have the cold tank. Waste tank. And of course the hot tank. We shall have, that is the hot top-up pump. Hot top-up pump, and that will be the cold. Yep, cold. Yep, a cold top-up pump. think that's all we need, isn't it? So let's have a look and see what we've got. So we shall need our hot tank. To be a hot top up. T1. Oh, come on, can't spell anything. To be a cold tank D2. A cold top up D3. What else did we have? Filtration. Filtration D4. Oh, yes. And we had the other thing. Furnace. Furnace D5. Now we had the valve. Here's the digital valve. And the mixer. Right. So there are devices. The mixer, not the kit. Come on. Copy, done. So there are 8 devices that we want to control. So, how the hell do we do that? Yield. Jump to the start. Now, first up we want to ignite the furnace. So we shall load into R0, furnace, was it ratio, oxygen, OX, Y, oxygen, and load into R1, oh wow, furnace, ratio, volatiles, tiles. Right, now to ignite the furnace you must have at least 5% oxygen and 10% hydrogen. So we shall set greater than equal to, set R0, if R0 is greater than or equal to 0.05. So if it's 5% oxygen, and set greater than or equal to, set R1 if R1 is greater than or equal to 0.1, so 10% volatiles. And of course we'll AND, reuse R0, so we AND R0 and R1. So it must satisfy both of them or it's not going to fire. So we should just save furnace, activate, capital A, A-C-T-A.
Hydration critical.
Activate R0. Right, so that is just to activate the furnace. Confirm, we should only have one in there, we do. Export that code. Now, let's learn from that this time and switch off that hunger. Yoink. Right, that should make it a bit easier. Now, so that should just be setting the igniter. Right. So in there we have nothing. Switch you on. And it has fired. 62% oxygen. That's the world. Pipe network. I haven't set a chip, have I? Idiot. Right, try again. So I shall want hot tank, hot top up, cold tank, cold top up. Oops, there it is. Filtration. And our furnace. Right. Try again. Put you away. That should immediately fire. Boom. Heard it fire. Whoa! Okay, that's hot. That is very hot. 2200 degrees Celsius. That is a lot hotter than what we needed. I was aiming for about 2000 Kelvin. So that is more than what we need. So now that we have that hotter than what we need, I can start blowing in some of my recycled gas. I don't have anything in there at the moment, so I might just add some more gas into there just so we've got something to play with. So we should be able to now switch on that valve and add gas to that until the temperature comes back to about 2000 Kelvin. We'll set it to 2000 Kelvin or thereabouts. That'll be enough. So I shall just hook up something to there. I can do that. I can do that. I'll just butcher my whole plan there for a moment. Oops. Vent, thank you. Now normally this would just be recycled gas coming in from the furnace, but as I haven't used it yet, I've got nothing in there. So we now have some gas in there at 17 degrees. Hopefully it's a bit hotter than that, so as we're trying to recycle gas, it's maybe 500-600 degrees, not gas that's stone cold. So now I can set up the next part here where it sort of tests that temperature and decides whether or not to switch on that pump. Right, so we'll just have that one. Ignite. Ignite if ready. Then you want to check for hot top up. So we shall load into R0 furnace temperature. Now if the temperature is greater than 2000 Kelvin, so what's that, 1723? I'll just say 1800, what the hell. So turn it on if it's greater than that. So we'll set greater than for R0, set R0 if R0 is greater than 1800. We shall switch that on. Yes, we'll be happy with that. So just save to the pump, I guess. Save to hot top up on 0. That's all I have to do, isn't it? Confirm. What are you set to? 50 litres. I could put a... No, I won't. You could change that to a variable one so the closer it gets to the temperature, the less it puts in there, but let's not worry about that just yet. So if I export that, it'll blow gas in until it gets to 1800 Kelvin and then should switch off. What did I say? 18 Kelvin. Oh, I might change that to 19. So that's at 16, 18, 15, 23, is it? Boom, and you switched off. Good stuff. Right, so that's that one working. So it's igniting, it's cooling it down if needed. Now I want to suck it out into the hot tank, so I'll need to activate this one if it's above our temperature. So now we said that one's 1800. I might actually change that to 1900 because I shall now turn on the extractor. So once again we shall load into R0 furnace temperature. Right, so this time we'll say set greater than. So if R0 is greater than 1800, the gas is hot enough. We want to keep it. So save filtration on 0. Right, so turn that on until it gets to 1900, switch it off, but keep the pump extractor going until it's down to 1800. That should work, shouldn't it? Now nothing's on because we're below 1800. That's empty, yes. So now we have a lot of O2 now because we've just blown it in from that tank. Okay, so I may have to set up a routine that will adjust the mix just in case we get extra and unbalanced fuel in here. So it doesn't have enough hydrogen. So we switch you on now. Whoa, okay, we're hot. Okay, you both switched on. We're extracting the hot gases. Once we get down to 1620, you didn't switch off. No, that's not right. What have I done wrong? Right, weird. Okay, I really have no idea what happened there, but it happened. Now 1627, is it? You didn't switch off again. Or maybe the temperature in the furnace is still high. Because we're reading from the furnace, not from the actual pipe. I may have to put sensors on the pipe here. Furnace pressure. Furnace temperature. Right, so you're 1604 in there. 1604 here. Okay, so now you've switched off. You're still going. Right, so that's inflating that tank. 3.6, wow, that's actually blowing up pretty quickly. Right, and that is nitrogen, CO2 and X in it, and all of our oxygen and hydrogen is staying here. And as it pumps out the CO2 and all the other stuff, the percentage of oxygen and hydrogen will increase until it reaches the ignition point again, and it should fire again without adding any more fuel. Okay, so that's working the way it should be working. So that's working the hot side. Now if I put right, so I shall want to top up the cold tank when it's below our certain pressure. I probably want to switch this whole thing off when that reaches a certain pressure too. Definitely shut down the fuel when the furnace reaches a certain pressure. So let's actually just define the pressure in there at the moment. So we shall define a max pressure in there. We'll start off fairly conservatively and we'll just say 5 megapascals. Now I shall want to set the balance on the fuel gauge. So we want to set the fuel balance. Now, how the hell am I going to do this? So I'll need to know the ratio of oxygen and volatiles. So once again I'll have to load them in, which I can get from up here again. So if I divide the oxygen by the volatiles, that should be 1 to 2, so I should have a ratio of 0.5. So if I divide, so R0 shall equal R0 divided by R1. So that'll be the ratio between the oxygen and the volatiles. It should be 0.5. So oxygen is on 1, so if we haven't got enough we need to increase it. So we shall, R0 shall equal 0.5 minus R0. So whatever the ratio is, we subtract it by 0.5, and that'll give us how far over or under the ratio we are. So if we have too much oxygen, it'll give us a negative number, which will reduce the flow rate. If we have too much hydrogen, it'll give us a high number. If we don't have enough of that, it'll give us a low number. Yeah, so we want, so that'll be how far off. So we want the flow rate to be 0.33. So if we multiply that R0 by 0.33 or 33. Oh, come on, don't do that to me. The setting is 33, okay, so it's not 0.3, it's out of 100. Right, so that'll give me what I'm over. So we want the setting to be 33.3. So if we multiply that by 33, oops, try again, multiply into R0 by 33.33333. Right, so that will be the amount we've got to adjust our setting by up or down. So if we now subtract R0, so R0 equals, well, basically the setting we want, minus the adjustment we've just calculated. Now that could be completely wrong, so let's just write it to the housing. dB setting R0. How are we doing? 2000. That's definitely not the setting we want to put on the pump. Okay, so that's because we've got a crap ton of oxygen, isn't there? So basically we've just got to max it out at 100. So if I just now say, I'll take a minimum, with the opposite of it, R0 of itself, or 100 for the setting. And we'll probably want to put the max as well. R0, R0, 0, so it'll be a number between 0 and 100. Confirm, export. Get out of there. Alright, so now it's telling us to switch it to 100. Which we certainly can do. Which is all hydrogen. Which is what it should be. So that's now burning up the oxygen. Whoa! Okay, so we've got 5 mole of oxygen in there. That's good, you should be switched on. You're over at max pressure, we might want to put our high pressure limits on there. That's 1623. Oh, 16. And damn it, you haven't switched off. Okay, so it is very hot in there. There is a lag between the two. So I am going to have to put a sensor on the pipe. We can do that. Put you in there. Though if I call you the furnace now, I can't activate the furnace from that, can I? I can't activate the actual clicker. I can still batch the furnace, so that'll be fine. That's okay, that's okay, no panic. Got to be you in explosive orange. Need to switch you on. I shall need to rename you to furnace sensor. So we need to change that now. So it is a furnace sensor. Furnace to kit furnace, which creates a furnace, which is you. Right, so you shall now be so we shall see to a load. No. You should be you, and you. And you should be a saved batch. We only need to activate the furnace with that one. We'll still be reading from the sensor the ratios. So the furnace sensor is on D5. Switch you off. Furnace analyzer. Export. You're happy. You're all happy. Because it's cooled down, right. I still have a... Oh, because I'm blowing in oxygen. Stop doing that. Right, we have a heap of gas there, so time to get rid of you. We'll start blowing some of this stuff through the furnace just to get an idea of what we're doing. So, where's my magic wand? There it is. Oop. Right, and a coat of paint. Now we have the system charged up. Right. So now if I switch them on it, I have two of them blowing in at 50. That one blowing out at 100, I shouldn't be able to explode that pipe. That is switched on, that is going at 100. Yeah, good. If I now switch you on, that is going up in pressure very quickly now. And it is very hot. Of course that one's out in the open, so it should lose heat pretty quickly. I might put up some more consoles for that one. The 1600, I think we can blow that one out. By the time it mixes with the other tank, we should be pretty good. Of course I'll be able to use that, blow that into that tank to get that up to pressure, and I will cool that down via the radiator. So we'll have a cold tank and a hot tank, and this one will just be for recycling. Now I should have less oxygen in there now, so that's a lot better. That should stop messing up my experiments. Right, that'll do you. Now, where are we? Should be able to switch that back on again. Oh! Ruh-roh! I think I might automate that. Right, now we have plenty of pressure in our waste tank now, so we might set up our cold tank. So now I'll put that in above that because we haven't quite finished that one yet. We're still experimenting, but we shall put it in here. So we shall check for cold top up. So we are load into R0, cold tank, capital P, pressure. Right, now if we want to switch on the top up pump, if it's less than our max pressure. So we turn it on if it's less than. So we set less than, set R0. If R0 is less than max pressure, where did I spell that wrong? I haven't set it up there. I'm sure I put that in there. Max pressure 5,000. Right, max pressure. Boom, you're happy with that now. Now save to cold top up on R0. So if it's less than that, it switches on. That's good. That's good. Confirm. Export. You switch on, you start topping up. So we haven't jumped below 30. We're good. We should still be running. So now we've set the cold top up on. Now we want to check the cold temperature. Cold temperature. So we want to load into R0 cold tank temperature. Right, so we want to open the valve if it's too hot. So we set if it's greater than R0, set R0. If R0 is greater than, what's our cold temperature? We'll define that up here, shall we? Define cold temp. I think we've got about 600 Kelvin, don't we? I'll check that later on and change it if I have to. So is cold temp. So if it's less than if it's greater than the cold temperature, we were on a batch. The valve is on a batch, isn't it? It is. So we want to save a batch valve on R0. Right, so that's switched on. It is cooling down that tank. It should cool down to 600 Kelvin. So that's the cold tank there. It is cooling down. Of course, as the temperature drops, the pressure will drop, and it should pump more in, which it is. Pressure is just going up and down, so it is just adding in more and more as need be. We should have this one flicking on and off. That one will stay on until it reaches 600 Kelvin, and that should all settle down. So how's our tank going? He's still got a lot in there. I might need a faster way to evacuate that tank. Oh, because it's 93% oxygen. That's why it's going very slow. Right, I might have to purge this system and start again. Because you're only 3% oxygen. You're 3% oxygen, that's alright. You have no oxygen, that's good. So I think I'm just going to purge the furnace and try not to kill myself doing it. And vent. So now I'm not standing right next to it when I do this. Well, that was disappointing, wasn't it? Ha! You're expecting me to blow up. Right, I might just actually leave you in there for now, so if I can have a emergency purge valve in there, thank you very much. So, and give it a case of exploded anytime orange. Right, now what are we saying? Oh, you switched off, right. Put you back on again. You still want 100 on that one. Nope. $36 mole, right. Right, that's good. So now we're mostly hydrogen. What are you saying? Ah, there we go. Now it's looking better. If we look at the IC housing now, it's telling us to put it on 21.7%, which is probably pretty accurate for what we've got there. We've got 22% hydrogen, 3% oxygen. So that might be good. Now we've switched you on, we're good. We're sucking out gas. As the oxygen gets up to 5%, it should explode again. Waiting, 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 waiting. %, or thereabouts. And boom, there we go again. 1700, you switched on until it's cool enough, and that's switched off. Once again, that'll keep pumping out until the oxygen, so I think that's working. So you're saying, you're now telling us 28. So that's as gas exchanges between the furnace and the pipe. It is making adjustments there. So that's good. That's working. That's working. But I might actually be happy to send that reading to the mixer now. So instead of sending it to there, we shall save the save batch to the mixer, and it is the setting. Confirm. Export. You're now setting that. That is good. Now, do I want to automatically switch that on and properly blow myself up? Now this one we want to switch off when it reaches the max pressure in there. So that's our filtration. So if the temperature is high enough, switch it on. We shall also want to load into R1 is the hot tank pressure. So switch on if it's less than, switch less than, so set R1, if R1 is less than max pressure, so switch it on if it's hot enough but under pressure, so we need to add those two together. So R0, R0, and R1. Right, so if both those conditions are met, switch the filtration on. Confirm, export, that should switch off now. Oh, stop you. Need to set you as well. Well, there's not much in there, right. So on our hot top-up, where are you? Check cold, check for hot top-up, rightio. So if the temperature is high enough, put it in there, but we also have to check the pressure. So we shall load into R1, furnace sensor, pressure, so turn on if it's less than, so set less than, set R1 if R1 is less than max pressure, and of course we want to add those two together, R0, R0, R1. Right, so if the pressure in there is less than our max pressure, very good. Right, export. And because we are below 5 megapascals, that is still switched on. You'll hit temperature and you should stop. Any second now. 1623, boom, you're gone. Right. Now, you shut down, you automatically shut down, you have an auto shut down, you have switched off, it must be cold enough. What's happened to all your cold gas? Oh, did I completely run out of gas? Right, okay. I completely ran out of gas in there. Right. So, you're switched on. So, I guess I should just run it for a bit longer. And see how we go. As we blow a gas into there, that one will drop below the max pressure, and that should all switch back on again. Right, so you should have switched back on again. Turn you off. You are indeed back on again. Do I dare switch my fuel back on again automatically? Well, that should actually be running high on oxygen. It's running at 18. That's not right. Let's try and automate that. So when the pressure in here is less than than the max pressure, I can switch that on. Oh dear, this is a bad idea. So mixer setting. Right, so we shall turn on mixer. So we shall load into R0 the furnace sensor. Furnace FUNACENS sensor. To load our furnace sensor, the pressure. Oh, come on, power. Hey, gotcha. So we set, come on when it's less than. So we set, less than, set R0. If R0 is less than max pressure. If the pressure in that pipe is less than 5 megapascals, we're going to switch on the pipe sensor. So now we save batch mixer on R0. I'm having trouble spelling that because I just know that this is a bad idea. Okay. And export. What? What? It didn't explode. I've got a shitload of hydrogen there. 80% hydrogen. That is definitely wrong, that equation. That's all shut down. You shut down, you shut down. If I stabilise 5 megapascals at over 1900, 5 megapascals below 600. Holy crap, it's worked. Okay, so I just need to check this this equation here for that and make sense of that. Oh, I want to add it. Is that where I'm going wrong? So if you've got high oxygen, you get a high number there, subtract it, you get a negative. So you multiply it by that and we want to add it. Yes, we want to add it. There was 47 oxygen. Which is looking what it should be. Right. Now, that's looking like it's working. So let's crank up. Let's define the hot temp as well. What did we say that was? 1800? $1800, yes. Okay, so that should manage it all. Let's crank it up to 10 megapascals. And see if that's a bad idea. Everything switches back on again. I step back. Oxygen and hydrogen. They're not far off. Still saying use more oxygen. You shut down. You're still going. Once again, you're trying to go up. If I keep using the gas out of that one, so the temperature's still going. Is that because we're not pumping in enough out of the waste claim? Oh, because the pressure's too high in there. Right, so you're going to keep blowing in till 10 megapascals and you won't blow in when it's 10 megapascals. Right, dilemma. Do I put that at less than max pressure? Right, so I might actually say furnace pressure. So we add to R0, 1 megapascal. So now that should only switch on when it's a megapascal below maximum pressure. So that should get down to 9 megapascals before that switches on. So oxygen and hydrogen looking good. You can switch on because you're below 10 megapascals. But it pushes in at such a speed that it actually pushes itself back up again. Oh no, we're going good now. So it is now feeding the waste gas back into that hot pipe there to bring the hot pipe back down to the required maximum. So instead of just burning fuel to create all that gas, we're now reheating some of the waste gas. And we look to be working. So that is actually looking after itself now completely. It should shut down once that reaches 5 megapascals, or 10 megapascals I've got it set to now. I could probably crank that up to 20. Oh, just fired again. And we have our gases. I haven't done anything with the furnace, but that might be about all we got time for today. Success. So that'll be part one. You've probably got part one on the title, so you'll know that one there, but this has taken me a long time, so I think I'll just edit it up and sort of say that's enough. Come on, 10 megapascals and it's shut down. It's shut down. You're still feeding into there. Why are you still feeding in? Okay, so you'll keep feeding in there until the temperature gets down or you run out, because you don't have much gas in there, but that's working. That is working. Huzzah! I've just got to figure out the electric one now. That's kind of still slightly underdeveloped. But right, stage one, done. Yeah, time for bed. So, till next time. Yeah, you'll have to wait for part two now. To be continued. So, till then, happy building. See ya.